Hello everyone, welcome to Fantastic Solution. So today we'll be solving a Leetcode medium problem named as two-sum, which is where the input is sorted. And this has been quietly asked, in almost few good companies, let's say Amazon, Facebook, Apple, Adobe, Oracle, Uber, Google, Microsoft. So we can just look into this. We have a similar easy problem named as two-sum, but this is extension on that. So let's go through the problem and see, how we can solve it. So it says given one index array integer numbers. So we'll have an input array of numbers that is already sorted. So one of the constant is this number is already sorted in non-decreasing order. So all the smaller values would be towards the left side and the larger value would be towards the end of the array. And now we need to find the two numbers such that they add up to specific target numbers. So we're also given a target number, and what we need to, our final goal is to provide two numbers which are going to provide this final sum target numbers. Let these two numbers be number of indexes 1, index and 2, where this is the condition like index 1 is less than index 2 is less than a numbers dot length. And what our goal is in return the indices of the two numbers, which is index 1 and index 2, added by 1 as integer array of this of length 2. So the output of this output array should be of length 2, with the final solution. That's it. And let's see how they're returning it. So it says the target is 9. We have to return, we know that 2 plus 7 is going to be 9, right? So in output array, we are going to return 1, 2, which is, you can say, the first index and second index. Though array indexes start from 0 and 1, they are adding plus 1 into that. So the location of that. So that's totally fine. Even if we know the indexes of the array, like which is going to be returned, like provide this target number, we can add the plus 1 into that. The second is 2, 3, 4, and target is sum. So we know that 2 plus 4 would be equal to 6. So that's why 1, 3 is the answer. Now, the second answer is -1, 0, and target is -1. So we know we have to add two numbers, right? So -1 plus 0 would be the answer 1, 2. So that's the about the problem, and let us see how we can solve it. So one of the approach would be, if we add the map, right? We know the key values pair. So that is the approach of this two-sum problem, which is a easy problem. We'll be solving that. When we know like we store all the values in the map key value pair, and then in next iteration or in the same iteration, you can figure it out whether we know the already let's say if you're storing 2 and we are coming to the 7, we can already see whether 7 plus 2 is already into the key stored into map or not. And using that, we can return the indices as well. So value of the map would be the indexes of the numbers and key would be the numbers. But let's use the one of the good approach, which we have is the numbers are sorted. What can we do with that? So I'll quickly try to write the example first and then we'll see. So example is 2, 7, 11, 15, right? So it says, hold on a second. Yeah. So we have 2, 7, 11, and 15, right? Let's increase this input array, make it, let's say, 17, 21, 25. And let's say if our target sum was 9, so we know that these numbers exist in the like one by one. But that can all like if I'm reading this number going to I, and then I know if I'm going to second number, I can add the previous two numbers. But that's not the way to always solve it. What if let's say our number was like target number was something 19, right? So these two numbers are going to provide the answer, right? So brute force approach could be like go one by one and for this number check whether 17 exists or not. So that would be we go of n square. Then again we can optimize using certain map and all key value pair. But here what else in the linear time we can optimize? So one of the approach like can solve it, let's say the two pointer approach if the arrays are sorted for us here. So let's say we can start one I from start and j from the end, right? And we'll try to see whether these two values are going to add or it's coming equal to target or not. So if you add 25 plus 2, the sum would be 27, right? But our target sum is 19 only, right? Which is less than my current, the target, what we have received the current sum. So now our goal is to reduce this sum, the current sum, we need to reduce this, right? That's how we can, reach towards it. If we increase that, then definitely we know like we won't be able to reach to this answer. So if I have 2 pointers I and j, and I want to now decrease my sum, right? So which pointer should I move inwards? Should it be I or j? So since this array is sorted, and let's say always the smaller element should be towards the I and the larger element should be towards the j, right? So what if you are going to increase this I, right? So that would come to 7, right? So that would be 7 plus 25, which is nothing but 32, right? So sum is always going to increase if you're going to increase, this smaller array. So to decrease the sum, we need to decrease this larger pointer, right? Which is the j, because we know if we decrease it, or if we're going inward, then again we're going to get the lesser value. So now the next value would be 21. So now I is same at same place here, the 0th index. So 21 plus 2 would be 23. So now we got a lesser sum, but again, if you see, the sum is pretty, larger than the actual target. That means we again need to decrease our j pointer. So now the j will come here, and we can see 17 plus 2 is nothing but 19. So that's the entire goal. So let's say if we want to increase the sum, decrease the sum, then move the j pointer inwards. If you want to increase the sum, then move the ith pointer inwards. That's the crux of the solution. So hope this is clear, and let's try to then solve it. So solving problem would be now easier if you know the entire crux, since we have visualized it. So let's create 2 pointers. I should be starting from start, and j would be starting from end, numbers dot length -1. And let's create one sum variable, which will be 0. And now, try to start, adding these numbers. So while I is less than j, so we'll be running the loop till the time they are crossing each other. So if let's say I has come here and j has come here, right? So we know that we have read all the elements. And if they're going, the I and j are crossing them, then there is no pointer, there is no point, again sum it, because we have covered all the scenarios. So while I is less than j, till that time we are going to run it. So now the sum would be numbers of I plus numbers of j. Now there exist 3 scenarios. Either sum can be equal to my target, or it can be greater than, or it can be less than, right? So what if sum is equals to target? Then we know that we have found the solution. Then we need to return this output array, right? Which will have the 2 numbers, because we need to return the length of 2. So right, so we just need to return the current indices, indices plus 1, because if you see, we are here returning, even though 2 plus 7 is 9, so instead of returning 0, 1, the output is expectation is 1, 2, right? So we need to return the indices plus 1. Similarly, j plus 1. Now, what if else if sum is greater than target? So now, if our sum is greater than target, then we know that we need to decrease our sum, right? So we need to decrease our j pointer. Else, the else block would be, that means our sum is less than target, right? In that case, we can increase our I pointer. So if sum is less than what is the expectation, we need to increase, our pointer from here to here. Yeah. And at end of the loop, if you're not going to find anything, we can just return empty array. That's it. And now let's try to submit it. What it says, number is not defined, line number 11. Okay, so here it should be numbers. Now submit it. Right, so it got accepted. That's it. So the time complexity would be big O of n, because the numbers are already sorted. So we use 2 pointers, and space complexity is a constant, right? Because we're not using any extra space. So that's it about this problem.